Hello, my name is Dale Gottlieb.
And I'm James Balbin. And today we'll be talking about concrete canoe and the success over the past few years that we've accomplished, as well as our general practices. So, I'm James, and this is Dale. We are both part of the University of Toronto Concrete Canoe Team. This year I am the co-president, essentially, and Gunnels is our sponsorship director. So what we're outlining today in the presentation is essentially giving you a taste of what Concrete Canoe does every year, as well as what we've made significant advances in the past couple of years, as well as our hopes moving forward in what we'll improve upon. So, last year our theme was Scooby-Doo, as you can see. So every year we choose a theme for our canoe as well as our presentations and such, and we use that as the main aesthetic basis for the canoe, the presentation, architecture for it, everything essentially we do for that year. So this was last year's. This year our general theme is space at the moment. We're right now honing in on the exact part of space that we're interested in covering. That right now we're leaning more towards kind of a Star Wars-y or slightly sci-fi version of space rather than doing a realistic reproduction. It's more interesting and allows us more artistic freedom. So, about the team. We're an heavily undergraduate engineering team. We haven't had a graduate student as part of the team in quite some time, actually. And we've existed for about 20 years. There was a hiatus in between the last 20 years and the team before that, where the team wasn't existing and no one was running it. So right now we have around 30 members. It spikes to about 40 during major events we have come out. And every year we compete annually at the Canadian National Concrete Canoe Competition. So this year it's being held in Montreal and it's being hosted by McGill. So that competition normally takes place around May. And it lasts the whole weekend. And Dale will cover what we do in the competition. Okay. And recruitment as well.
So the first thing which we do, so the club has a very active role around the school community. So during Frost Week, we do a lot of recruitment to try and get first-year students to join the team. Since a large part of the people who help construct the canoe and help us at weekly meetings are from the first-year body, our event at the Frost Week is very important to try and get people to join. So an example of what we do over here is we just have people run the canoe down the field to, like, part of the idea is to see that it's not very heavy, which you would expect from a concrete canoe. And, you know, you have like 5 people carrying it, but realistically 2 people can hold onto it at the same time. So after they run it down, we have them lift up the canoe and try and determine the weight of it. So a lot of people, you know, way overestimate it. The idea of a concrete canoe, you know, they say maybe 500 pounds sort of thing, right? But realistically, this canoe is actually only about 90 pounds, so a lot of people get it quite a bit off. So on top of that, we, following the Frost Week part, we participate in the club's fair. So this is where we just have the canoe behind us. We talk to Frost who come up to us, and they ask us about what the club does, and the hope here is to try and answer some of their questions and show them that it's not specifically a design team, and that anybody with any skills, such as in design work or presentations, can be an active member of the club.
So normally at the club's fair, one thing we like doing is we like bringing our essentially compression cylinders, and we like having a basin of water, and we just toss the compression cylinders in and show off the fact that our concrete floats on its own. So we just chucking large pieces of concrete into a body of water, and it rises to the surface, and everyone's always amazed by concrete floating in water.
So a big part of our club is, of course, the annual competition, which we participate in. It's sponsored by the Canadian Society of Civil Engineers. It's an annual competition. It's called the Canadian National Concrete Canoe Competition. So each year, 12 universities compete from around the country. This past year, it was hosted at University of Toronto, and this coming year, it's at McGill University. So each team is responsible for transporting their canoe there and all of their theme stuff with them. And we have universities from as east as Moncton and as west as University of British Columbia. So with the UBC team, they actually spent 4 days commuting across the country with a canoe behind them in the trailer. So some of these teams go quite a distance, and to fund that, they had to get over $30,000 in sponsorship just to help transport the canoe in a train to another one of their competitions. So at the competition, University of Toronto typically places best in Ontario, which is 4th overall. the top 3 spots are typically taken by the French teams, who have a lot more time developing their canoe and a lot more man hours throughout the year. So, but typically, being best in Ontario is a very good role to have, and we also do very well at the design stage of the canoe. So the competition consists of 4 parts. So it's not specifically the canoe which you construct. You also have to create a technical report which describes all the details about the canoe, all the developments that the team's made, and all the innovations that have happened year over year. We also race the canoes. So a lot of people like to say that it's a race to the bottom of the lake, but you can see that the canoes float. They hold up to 4 people, and it's a very active competition. So, some of the teams are very aggressive paddlers, so the canoes can handle a beating. There's also a design presentation, which is just a very brief couple-minute presentation where you just go over the innovations that your team has had over the years. And finally, the judges come and look at your finished product. So how smooth the canoe is, how many cracks there are after the competition, and just overall design of the canoe is judged.
So traditionally for the competition, we tend to place highest in our point rating to our man hours and budget. So compared to the French teams, who have budget in excess of 4 times ours, as well as 4 times the members and man hours put into the team, we have a much higher point to essentially effort ratio in the entire competition. So essentially our main sticking point is we just need to increase both budget and time. And then we can pull ahead of the French teams and finally beat them.
You make a new canoe every year?
Yes, we make a new canoe every year.
Every year the entire canoe changes, we reconstruct it, and we change the theme and all the presentation stuff as well. So every year everything changes basically.
And we vary the design over the years quite heavily. We'll cover that later in the presentation.
Yeah. So one of the major areas where the French teams tend to beat us and where they put in a lot of man hours over us is the paddling team. And we're hoping that this year we have a new paddling captain, and we're doing a lot of new stuff to try and improve our paddling team. So of course we're booking more hours for exercise training, and we're also hopefully getting more experience in the canoe. One of the problems which our team has is turning the canoe, which is very, very difficult, actually. And if you look at the French team, somehow they can turn on a dime, and we're trying our hardest to try and catch up with what they can do. So we're renting a pool at Afterburn Fitness, which will hopefully give us some experience in the water, just sort of paddling. We've, of course, increased the number of training sessions to increase the hours of people working out, and we also have a more intensive workout regime to hopefully make stronger paddlers who are able to push the canoe to its limits.
So when the club was revitalized back in 1999, our first canoe, it had a rather tumultuous first outing. So this is a picture of the first canoe we built after the 20-year hiatus between when the club stopped working and when we continued the club. So this canoe was, I think, weighed something like 250 pounds or something. It was a behemoth, and during the competition it worked enough. So here's a picture. You can see the silver duct tape where they reconnected the canoe back together for the picture. And we like to think we've made quite a few advances since then. So one of the major steps we've taken in the last 2 years is we used to have a Panda simulations program that was made by a graduate student back in 2004 or something. And essentially it's gotten to the point where everyone on the team no longer knows how that program worked, and we were just putting numbers in and just getting essentially our bending moment envelopes and such. But last year, what we did is we sat down with our structural analysis team, and we recreated an entire program in MATLAB. And the program, what essentially it does, is it takes in SolidWorks models, and we can assign it loading cases, such as you have 4 paddlers who weigh this much, and they're using this much surface area for their knees and their toes. And the program will take that and output strain and stress models. So here are 3 pictures of the canoe from last year. It shows the SolidWorks modeling, and you can see the grid on the canoe, and that is how the MATLAB program solves it. It uses an FEM solution model. So we'll look at the first main output that we like looking at is the 3-person loading case. So our main slalom event, it's 3 people in the canoe, and the slalom is about 300 meters back and forth, and you have to weave between cones. So So what we do is we run that through the program, and it outputs essentially the maximum compression tension, and then we combine the strengths, these strains, to get our maximum loading. So using the maximum loading, we can figure out essentially the thickness we need out of the concrete on the hull, the maximum strength we need from the concrete, and using those, we can figure out essentially the rest of our parameters for the design. So, moving on. So here we have a bending moment diagram and a shear diagram, also for the 3-person loading case. So you can see we have it output the moment diagram across the length of the canoe, which is in red here, and the shear forces, which is in blue. You can see how the shear forces are grouped by where the paddlers are sitting, where it maximizes shear force in that area. So, then finally we run through all the other cases with 2 people in the canoe, 4 people in the canoe. And essentially we make a master diagram that creates the envelopes of the maximum stresses that the canoe faces. So then we look through the diagram and we pull out essentially the maximum stress that the concrete will feel. And then we design for that and alternate the hull thickness depending on this. It also outputs stress plots. Stress plots are quite important for determining where exactly we need ribs along the canoe and the thickness of those ribs. So the diagram on the left shows our internal stresses in the canoe while it's being loaded. So underneath the canoe, you can see the slightly gray area is how we model our buoyancy forces. So we essentially just have a pressure over the entire bottom. And the bars on the top model the paddlers, where the longer beam represents the knee and the shorter beam represents the toes. So you can see localized around the areas where the paddlers are sitting is a high degree of stress right around the ribs. The ribs you can see are indicated by these darker parts where the stress is much lower. So that essentially shows us how the canoe will fold in on itself with paddlers in it, along with buoyancy forces pushing the sides of the canoe in. Then what we do is we look at the external stresses. So we look at the bottom of the canoe and essentially essentially spalling of the bottom of the canoe out to design for that as well in the external stress diagram. Okay.
So the way which we design the canoe is we create a SolidWorks model with our hull design team. They then export it like this to put in a technical report. And we send out we export the model to a Panda program, which then sends it to a CNC machine, which is able to mill it out of a mold. So if you look at the SolidWorks model of the canoe, you can sort of see the top view. So this is when we place all the molds together, you sort of get a female mold of the canoe, which we then put the concrete onto. You can also see the length of the canoe, the cross section, and you can see a design of the gunnel around the side. So the canoe has a gunnel going around the edge to provide more support once the paddlers are loaded. So the length of the canoe is about 20 feet long. So to give an idea of scale within the model. So once we have the mold design together, we can export it. So one of the things which we've done recently is actually try and optimize the way which you put the mold pieces onto the styrofoam. So the way that works is we get about 20 different thin layers of styrofoam, and we stack them up on top of each other to get the full thickness of the canoe. So this past year, we put them on in different ways. So that's the back of the canoe, and here's kind of leading to the front of it. And the idea behind this is we are actually able to reduce 1/3 of the material. And this foam is expensive. This year we're expected to spend about $500, $700 on the
foam alone.
Yeah, on the styrofoam alone, and that's not including the cost of the CNC machine. So reducing the milling setup and material consumption is quite a big impact on the overall cost of the team. On top of this, the new mill design, we've had problems in the past of the styrofoam not layering on top of each other properly, which causes sort of cracks to form within the canoe as we layer up the concrete. So what we've done is we've put in pilot holes, which when we layer up the milling styrofoam, we can put pipes through, which holds it in place. And one of the problems which we've had this past year is that we sort of just cut it straight down through the styrofoam, which sort of allowed that connection to move side to side. We solved that by putting in a massive bolt going through the middle of the styrofoam. But this coming year, we're hoping to layer up the concrete in sort of a way that bricks work to keep it in place and put a pipe straight through that. So hopefully the structural integrity of the mold is going to improve significantly this coming year. On top of that, recently we switched from a female mold to a male mold, or the other way around. We switched from a male mold to a female mold. This was back in 2013 with the Jinkies canoe, and the reason behind this is we found that the male mold, because we hand cut the concrete onto the mold, we had a lot of problems with sort of leaving fingerprints and uneven finish on the top of the canoe, as well as a problem of the concrete sort of setting and pulling down the side, which made the gunnel thicker at the bottom of the concrete, or at the bottom of the canoe. So switching to the female mold also made it easier to remove the canoe from the mold without destroying everything, so we can easily just pull it apart. One of the advantages with the male mold is that it allows you to mill in the gunnels to the side of the canoe, or not the gunnels.
Well, the gunnels and the ribs.
Yeah, the gunnels and the ribs. So with the female design, we're no longer able to use ribs, so we've had to come up with some new tactics to sort of improve the structural support of the canoe without the ribs going along the inside. So on top of that, switching to the female mold caused a couple of problems with the gunnels. So previously, as we were making them, we could easily pat it in underneath the mold, and it'd have a flat surface of the table to sort of keep it consistent going throughout the canoe. One of the problems with the female mold is that as you pat it up, the gunnels sort of droop in to the middle, and it sort of messes up the structural support that you calculate from the programs. So in order to fix this, James actually came up with the idea of putting MDF boards around the top. So it's just a thin piece of wood that we wrapped with tape to stop it from sticking. So the idea behind this is that as we're casting the canoe, we can actually pat on the concrete, and we have a place to sort of build it up to. It keeps the lining consistent, it keeps us aware of how much concrete we're putting on, and it reduced cracking as the canoe was drying. So one of the problems when it dries is that the gunnels crack, and providing the main structural support is a very bad thing if these start to go. So we reduce the cracking during the drying process.
An interesting problem that came up with the MDF installation is that due to the MDF covering the top of the mold, we weren't able to check if the gunnel was properly laminated between the concrete matrices. So one of the problems we had was when we pulled off the MDF boards, we found out that our inner layer of structural mix had delaminated from our internal carbon fiber mesh. And essentially what we had to do is we had to create a makeshift mortar out of concrete mix and stick them back together with this mortar pasted in between. But we got essentially all our strength back just by doing this, and it was an interesting problem to have to try to solve. So mold finishing is another place where we've tried to drastically improve our process. As Dale mentioned, the reason we switched from a male mold to a female mold is due to the fact that when you cast the canoe, the outer surface that doesn't touch the mold tends to be much rougher and have surface textures. So with the female mold, what we've tried is we've switched. In the past, we've used shrink wrap. So we've coated the entire mold in shrink wrap. We've heated it. It's shrunk down, and that creates a smooth casting surface for you to cast upon. The problem with using shrink wrap is that it's both easy to tear while casting upon it, and it doesn't release nicely. So what we've done is we switched to an epoxy resin release. That was last year, and what we found out is that even with the epoxy resin release, what we'd have to do is we'd have to essentially coat the epoxy resin, even though it's supposed to be a release agent. We have to coat it with another release agent just to get the canoe out of the mold without having to rip apart the mold. So what we found actually is during testing this year, is we found that tuck tape actually works remarkably well at providing a smooth surface that nothing sticks to. So what we've done is we've switched from the epoxy resin coatings to essentially an all tuck tape coated mold. So what we've done is we've had our mold and we just layer tuck tape going along the mold to provide the smooth casting surface. And then we cast upon that, as you can see in the right picture. So, as Dale mentioned, with having to maintain structural integrity while removing the ripping, what we've done is we've decided to do a variable thickness along the bow of the canoe and the cross section. So what we've done is in the areas of the canoe where structural integrity is not as required, such as the top, we've made thinner and we've made the base thicker going down. So this saves both weight and it increases the strength. So we had a major problem with ensuring that the thickness was correct. So what we've done is we've taken toothpicks, we've measured out the required thickness, and we've marked it off, and then we stuck it in the mold. And then using that, we cast up to the marking on the toothpick to ensure that it was the correct thickness. And then, to ensure the accuracy of our thickness, we essentially got a massive 3D laser scanner and we ran it along the cross section of the canoe to check the thickness. So here's the output of the scanner, and essentially it shows the cross-sectional essentially distance along the entire canoe. And we found out that we were quite accurate, and we got basically within 0.5 millimeters of what we wanted. So we were quite happy with how that turned out.
So of course, a major part of the club is the concrete design. So last year, James and I actually ran the concrete design, and now it's some new people. The most important part of it is that it's actually 10% less dense than water. So if you look at the stats over here, the unit weight is actually 925 kilograms per meter cubed. So if you took the canoe and made it into a block of concrete, it would still float on the water. So that's one of the major differences between our club and traditional concrete design. On top of that, our flexural strength is 7.5 megapascals, and our compressive strength is 5.3 megapascals. So what that means is that we have terrible compressive strength compared to actual concrete. You wouldn't want to put this in a building or anything. It's quite weak if you push down on it, but our flexural strength is actually great. And the importance behind this is that a lot of the forces that the canoe feels is actually the flexural strength. So where the paddler's knees are, as well as just the bending of the canoe, really stresses the concrete in this way. Yeah.
Actually, a curious thing that comes out of our flexural and compressive strength is that our material properties are closer to that of like a dense wood than they are to concrete, which I always find interesting. So essentially, both compressive and flexural strength ratio is more akin to that of a Douglas fir than any concrete you would find out in the industry.
One more thing to talk about the concrete. The admixtures that we use, a lot of times with actual concrete, they just put in like rocks and really hard things. With us, we have weight in mind. So we have things like glass cenospheres, which are just sort of expanded glass beads that are made of recycled materials, which help keep the weight down while acting as an aggregate within the mixture. And we also use things such as expanso, which is like basically the same density as air. So if you when you touch the stuff, it sort of explodes around the room. And it's hollow glass, so it helps again to sort of act as a filler material to keep our weight down as we increase the strength of the concrete to what we need to keep the canoe alive.
I guess that's another point of interest for concrete is that none of our aggregates are bigger than 300 microns in diameter. So that's, what is that? That's 10 to the minus 6 of a meter.
So one of the big parts of our design is we need a lot of flexural strength. So to do this, we actually use reinforcements within the concrete. So for example, when we construct the canoe, we go through 4 layers. The first is a very weak surface layer, then we have a structural layer, and then we put in a layer of carbon fiber, followed by 2 more structural and finishing layers. So the idea behind this is the carbon fiber provides a lot of the tensile strength within our canoe, and the concrete provides the compressive strength. On top of that, within the structural layer of concrete, what differentiates the structural from the finishing layer is we put in some PVA fibers. So the idea behind this is if you put in a random matrix of fibers and you try to pull the concrete apart, it puts a lot of the tensile force onto the fibers rather than the concrete itself. So through these innovations, we can actually improve the strength of the concrete significantly. And again, if you go back to the graphs, you can see that this is for concrete with a carbon fiber layer, and that one's for a concrete beam without it. So this one's going at about 7.5 when the concrete fails, and that one's under 5. So this carbon fiber layer within our test beams actually improves the strength significantly.
So canoe construction. Every year we have a dedicated day, it's actually 2 weeks from now, where we sit down for the entire day. It takes we start at 10, we end at about 11 at night. And we sit down and we cast the canoe. Essentially, this requires the entire team. We get about 40 people out, and we all sit down and cast the canoe. So essentially how that works is, before the actual event, we have the main concrete leads of that year. They pre-bag all our concrete mixes, so we have each individual 4-liter bag of pre-mixed concrete. And then on the day, all we do is add our water mixtures and our admixtures to that to increase the speed of casting. And essentially, what happens is we cast finishing layer, cast structural layer on top of that in multi-stages. So we'd have the finishing layer going across the canoe, and then before the finishing layer is finished, we would start with the structural layer to ensure that the concrete is not set and we can get good bonding between the layers. So, as mentioned before, we checked the thickness with our newfound toothpick method to ensure that our concrete was the correct thickness. So for finishing, after our curing process, which we cure in a humidity tent we make out of the mold, so since we take particles and we stick them into the mold and drape a vapor barrier over that and seal that with humidifiers inside the vapor tent for about a month to ensure proper strength after casting. Then we demold the canoe, and we essentially sit down and get out a bunch of sandpaper ranging from 60 grit to 1,200 grit. And then we sit down and sand the canoe to about 1,200 grit. After that, we stain the canoe and apply a sealant layer. This year, we're not going to be staining the canoe though, because they've implemented a new rule banning stains, and what we have to do is pigment the concrete for the canoe. So essentially what that forces us to do is revert back to simpler aesthetic designs. So simple gradients, not very clean barriers between colors. And we've also experimented with ideas of essentially pigmenting extremely low density would basically be just cement, and we'd have that as essentially a sacrificial finishing layer on top of our structural mix. So we can essentially just paint on this colored cement, which circumvents the rule because it's pigmented. So,
one of the major changes, as I mentioned, between the male mold and the female mold is that with the female mold, we're no longer allowed to put ribs in the canoe. So the reason why we used them traditionally before was that it provided a lot of structural support for the canoes. So paddlers, when they were in the canoe, they would rest their knees on the ribs, and because the ribs were significantly thicker, it would sort of decrease the forces felt by the rest of the canoe, right? Which allowed us to decrease the weight of the canoe significantly. So the picture here, it's just a picture of a rib, but it's from our canoe from 2 years ago, I believe, Cheshire's Grin. This was the lightest canoe that we've ever made, and it's one of the lightest canoes ever at a Canadian competition. And one of the innovations that we used was the idea of putting ribs into the canoe. So we didn't use ribs last year, which turned out okay, but it really forces our canoe to its limits, basically. With the paddler's knees no longer on their ribs, this past year we actually got a hole in the canoe near the end of the competition because somebody's knees punched right through the canoe. We're not going with ribs again this year, and we're hoping that again the failure happens at the end of the competition,
well,
if at all.
No. We've increased the thickness this year from last year. Last year we went to about 12 millimeters on the base of the canoe where the paddler's knees rest. We've increased that to about 16 millimeters.
Yeah.
So we're hoping to prevent any punching shear that could go through.
Yeah, of course we're hoping to prevent it.
This person also had ridiculously skinny knees.
Yeah.
And we're very top heavy.
Yeah.
Pushed down, they stuck their knee through the canoe.
They were made for paddling, which was bad for our canoe. You have to humidify your concrete. So concrete sets better if you keep it at high humidity versus if you just let it cure at sort of a room condition. So to help set our concrete, we actually built a little humidity tent. So this is just sort of a wood block with film going around it, and we put a humidifier in there. So this keeps our concrete at 100% humidity and helps it set to great conditions for good finishing product. So to replicate this, over our canoe, we actually put a tent of the same material, and we laid humidifiers across. So we would take this thing and just put it in there. And again, it keeps our canoe at 100% humidity, and it leaves us with a very good finishing that if you just left it outside of the humidifier, you would get a lot of cracking, and it would significantly decrease the strength of the canoe. So,
Okay, so our major goals in the next coming years is what we want to move towards. Is we want to move towards shotcrete. That way, we eliminate any possibility for casting defects made by people placing their hands in the wrong place. This ensures that we get the same thickness throughout the canoe. So essentially what we're doing is, right now we're drafting up plans for making our own shotcrete gun. We've sourced the compressor already, and we've started creating our piping system for both pumping the concrete as well as the actual nozzle in the gun itself. And essentially we're essentially following in the footsteps of the French teams. There's one French team who does this, it is Laval, and they essentially get a really nice finish on their canoes, which is what we're hoping to get. This also requires major overhauls for our concrete side. So what we've basically done up to this point is we've designed all our concrete mixes to be cast by hand, so they're essentially zero slump, if not like 0.5 millimeter slump. And what we'd have to do is we have to drastically increase the workability of the concrete so we can shoot it out of the gun. And as we mentioned before, we have to implement these new finishing techniques, so pigment use rather than staining. Well, I guess that wraps up most of the presentation.
So in conclusion, the thing to take away from the presentation is that for something as relatively simple as building a canoe, I guess made out of concrete is the challenge, but for something as simple as this, there's still a lot of problems that you have to face, and there's a lot of innovative ways that engineering can be used to circumvent these issues and design a great canoe that will hopefully place first in the Canadian National Concrete Canoe Competition. So thank you for your time, and if you have any questions, we'd love to answer them.
Thank you. Who knew it could be so complicated? So,
Whose cement did you use?
We use Lafarge's at the moment. So Lafarge provides our cement.
Are the paddlers allowed to wear knee pads or anything to spread the stress?
Yeah.
They're allowed small knee pad blocks, but what we found is that the blocks essentially get worn down by rubbing against the concrete as they paddle, because the concrete's only sanded down to about 1,200 grit, and that still tears through the knee pad essentially. So while they do help spread the load, they're not a final solution to the problem.
You couldn't just use bigger knee pads and softer ones and spread.
There's a size limit on the knee pads. They have to be under, what is it? It's a quarter foot by quarter foot. No, it's much smaller than that. They have to be very small, essentially. It's just a little bit bigger than most people's knees is what we're allowed.
Eric?
How do you test for eccentric loads and for heavy water conditions?
So for heavy water conditions, essentially what we tend to do is we tend to just increase the safety factor of all our calculations by a factor of 4, 5. Yeah, we have about a safety factor of 5 in all our calculations. So that takes into account, we hope takes into account any heavy water conditions we could have, as well as excessively heavy people being in the canoe.
Paddles similar to regular canoe
They're
paddles?
just regular canoe paddles. We're upgrading to new carbon fiber canoe paddles to decrease weight and hopefully increase paddling power output from the paddlers.
Are the design regulations international or?
So the American and Canadian competition, although separate, have basically the same rule set. The Canadian competition tends to follow in the footsteps of whatever the American competition implements. So this year, the whole staining being banned is due to the American competition banning it last year, and the Canadian competition has decided to just follow along and keep that going.
A lot of the teams, like some of the French teams, compete in both the Canadian and the American competition. So it's important to try and keep the rules similar so that they can go to both of them without being disqualified.
Are you allowed to tap outside the university for design ideas?
We're not allowed to tap outside the university. Essentially, yeah, we're not allowed to tap, yeah. You have to keep within the engineering faculty at your university for members, as well as design ideas.
Even for hints?
Al?
Yes. Are you planning, or is there a plan to stimulate competition in racing your canoes? You know, there is a canoe competition, regular canoes.
Yeah.
Do you plan on participating in that?
We hosted the competition last year, actually. So last year it was hosted in Toronto. So last year we hosted the competition.
Yeah.
So, and also we've been taking steps to help out the newfound teams in our area. So Waterloo recently started up their concrete canoe competition team again 2 years ago, and we've been helping them out designing their concrete as well as getting the numbers they need for getting essentially their club off the ground, as well as Ryerson. Ryerson has also started their canoe team in the past 3 years, and we've also been helping them get off the ground.
How many countries are involved?
How many countries?
Yeah.
So we only go to the Canadian national competition. Last year, actually, a Japanese team tried to register for the competition, but they were disqualified because they're not Canadian.
Don?
Like you said it before, but when is the competition for Ontario?
The competition's in May. I think it's the 12th to the 15th this year.
It's after one of the reasons why we don't compete in the American competition is because it takes place during exam season, and it would conflict with a lot of our schedules. So the Canadian competition happens right after exams finished at the end of April.
Do you document all the design work that you do?
Yeah, for the competition, they require us to make a technical report as well as hand in an engineering notebook with that technical report. So in those, we document all the rough calculations we've done, the programs we've used, the inputs we've provided for those programs into that book.
And that's accessible by future teams?
Yeah, that's accessible by future teams.
Okay.
And the
What do you do
competition?
with the old? What do you do with the old canoes?
We keep about 4 years worth of canoes on hand, so we have 5 right now, and we've run out of space. So what we normally do is we destroy the old canoes.
They don't go to somebody's cottage?
Well, normally people don't want a 100-something pound canoe in their cottage.
We have alumni events where people get to come and they stand on the canoes
Yeah.
on like the Gunnels and split it in half.
Mhm.
And then any pieces that are nice, so like the part that says Toronto on it, a lot of people like to take, and any part of the theme as well. So people get to cut it apart and take the pieces. I think this coming year what we're planning to do is take one of the canoes and
Toboggan it down a hill.
yeah,
And
exactly.
we're planning to use those toboggan down the hill.
Jim, at the back?
So you haven't contributed canoes to the Canadian Canoe Museum in Peterborough?
We tried.
I think actually someone asked us on the street because we were carrying our canoe down the waterfront, and someone came up to us.
As they were trying to sell us.
They were trying to sell us a canoe because for some reason they were confounded as to why we were making a concrete canoe, and they were just like, "Why would you do that? I have a carbon fiber canoe. Would you like to buy that from us?" No.
My father-in-law has 2 canoes in the canoe museum.
Oh, okay.
Over here?
I was going to suggest, why not put the canoes up at camp?
We're planning on putting one of the canoes from 2013 up there. We recently talked to faculty about that this year, actually. And essentially, the problem with that is that the Civ department doesn't want to be responsible for taking care of the canoes. And essentially, people are pushing the responsibility around for the canoes all over the place. So we haven't had a yes to finally moving the canoes up there.
Right, your camp's going to be renovated.
It's going to be renovated?
So there's going to be a bigger building, more space, what have you. So maybe you want to hang one of these up somewhere.
Yeah.
If you've got a space to space.
Mm-hmm.
Talk to Brenda McCabe.
Yeah, Brenda was interested in actually having the one we have down at Sunnyside at summer camp, at the Civ camp. But it's never come to a final decision on whether they actually want it or not. She just expressed interest. We're kind of floating around.
Any other questions?
Is there much reviewing of the technical presentations of the other teams? Or
Yeah, normally we don't. The technical presentations aren't usually recorded. So what we normally do is we go through the other team's technical reports and see if there's anything interesting or innovative we can essentially reverse engineer and possibly utilize in our designs.
One of the innovative things that another team used 2 years ago, I think, is they created a program which is designed for like neural connectivity or something in the brain, and they applied it to concrete. So the idea was they could go through the network of like billions of different combinations of materials in the concrete and hopefully optimize the best one by using some program that was designed for the brain in some way. It was quite an innovative idea.
Yeah. While that idea was cool, it's hardly usable for anything but like one-time use. Essentially, what they had to do is they had to sit down and go through every possible iteration of your admixtures, your cementous mix properties, and they went through all of that. And even with going through, 300 different tests, they only have 2 data points for each modification, and essentially it's rather pitiful for getting a final design out.
Eric?
Do you have any ratings for speed and maneuverability?
This year we've actually been doing drag tests. So what we've done is we've taken one of the, what's it called? We've essentially taken a, what are they called? Essentially it's a machine that just, you have water flow down and you stick objects into it. I've forgotten what it's called at the moment. It's used for testing drag. So what we're doing this year is we're making small foam models of our potential hull designs, and we're sticking that into the stream and registering how much drag is and force is apart upon the canoe. What we've also done is we've inserted it sideways to see how much force is pushing against the side of the canoe, essentially give us a ballpark figure of how difficult this canoe will be to turn.
Bob?
How much support and encouragement do you receive from the faculty? For example, do you have an advisor?
We have a club advisor, Carl Peterson. He's a cement prof. Essentially, faculty support is rather minimal. The faculty doesn't tend to get involved with clubs. What we normally go to them for is if we have issues or there are safety concerns that they've brought up, and they'll deal with that. But none of the design input usually comes from faculty. It's all done by us.
Again, following up in terms of learning from others, do you have access to the designs they use in the American competitions?
Yeah, so the American competitions, they have a giant repository of all this top 5 teams from their national competition. All their tech reports get posted up there, and we tend to go through those and see if there's anything interesting.
Okay. We are.
Have any teams ever been disqualified for design?
For design, not to my knowledge. We've had teams that have been disqualified because their canoe was broken in half, but nothing else. we have a history of breaking Western's canoes, where we end up hitting them during the race, and they end up splitting in half, or we puncture a hole in them. It kind of happens. So we usually end up sending Western home with a broken canoe.
Is that considered a body check?
High test early setting cement? Use a high test cement early setting?
We don't use actually early setting. We use a rather mid-range. So we just use a type 1 for our general purposes.
You can tell Barry's a cement guy.
Spent my life in the cement business.
Yeah. We don't tend to play as much with the actual cement itself as we do with aggregates and admixtures. That's what we tend to do most of our design work in, rather than actually modifying the cement specs.
How many different events do you have? You talked about going around obstacles and so on, and straight racing. How many different maneuverability?
There are 3 main types of races we do at the competition. One is the slalom, there is a sprint, and there's an endurance race. The endurance race is about 1,500 meters, and it's 3 laps around a bunch of pylons. The sprint is about 300 meters or so, and it's a pretty short course. You do 2 laps around it, and it's essentially just a series of pylons which you have to navigate through. And the sprint is just a single straightaway.
And the winner is picked, and combining the results?
Yeah, the results are averaged together for a score at the end.
Where is the course in Toronto?
We were at Sunnyside last year for our competition.
Inside the breakwater?
Inside the breakwater. Actually, a funny story is a couple years ago, 2 of our previous project managers, now alum, decided to come back and try to paddle their canoe, because they never actually paddled the canoe they made. So what we did is we carried the canoe down to waterfront, past the break wall, and we got into the canoe and we started paddling out, and we realized that once you pass the break wall, the waves come up higher than the canoe is. So we started taking on water. And we had to turn around and go back to the dock. And just as we were going to dock up, the dock, which is slightly submerged in the water, got hit by a wave, and the wave came up, and the dock went through the bottom of our canoe. And was a rather disastrous outing. Not only did we not get where we wanted to go, we came back with a canoe with a giant hole in the bottom.
So you're writing a book called 25 Ways to Break a Concrete
Yeah,
Canoe.
it was pretty sad.
Bill?
Are you allowed to put any keel at all in the whole design?
I'm not actually sure if we're allowed to put a keel. We've played with the idea, but we've never found that it was advantageous to have a keel.
Wouldn't that help on the maneuverability and challenge floors?
It would, but why haven't we put a keel? I think it's against the rules. I'm not usually part of the whole design process. I just make sure their deadlines are intact, and I spend more time in the concrete side of the process. But I'll look into it, actually. I'm not sure. I have a feeling it is not allowed, but I'll look.
One more question, if anyone has one? No? Okay. Thank you very, very much, James. And, okay, so thank you all for coming, and look forward to seeing you next month.
Good.
Good. Thank you.